Welcome to another Mr. Paul video. Today is 10.2 properties of reflections. Now, reflections is another math word for flip. Let me show you what I mean. Let's just say we have an object, right? A shape that looks like this. It's an index card. If we're saying that it's going to be reflected, we're saying that we're going to flip this over. So for example, we might flip it like this. Or for example, we might flip it like this. But this flipping of this index card is a little bit easier than flipping something on paper. How do we demonstrate that on paper? And how do we show which way that it flipped? For example, like this, like this, like this. So when we are discussing this video, we have to keep a few things in mind. That whenever we see the word reflection, we're thinking of it as a flip. And this will be number 2 of 3 types of movement that we are going to be learning in these videos. Once again, on paper, when we're discussing the starting point, we're talking about the pre-image, okay? The starting point is how we can take a snapshot of the before, and it will be labeled A, B, C, D. And then the image, which is a snapshot of the after, will be labeled A prime, B prime, C prime, and D prime. And once again, if you've been watching the previous 2 videos, to move a shape, you instead move each corner. You don't move the center of the shape. So let's take a shape, for example. We'll take a triangle and we'll label it A, B, and C. Now, to say that we want to flip this shape over, we better identify which way we would like to flip the shape. So for this first triangle, we're going to flip it this way, like this. Okay? But as you can see, if this was my shape and I tried to flip it over right on top, it can get very confusing as the other shape would be lying right on top of the previous shape. So instead, what math has decided to do is give us something to flip over. Okay, so say for example, this line. This line could be an axis on a graph paper. This line could be a random line in any given space. But we're going to flip it over this line all the same. So the way that you flip it over this line is we're going to try and create what's called a mirror image. I want you to imagine that you're facing a mirror. This is us, and we're facing a mirror. This is a mirror. On the other side, it looks like there's someone still with you, right? You're looking right at somebody who's looking right back at you. That is your reflection, if you've ever looked at a mirror. And if you've ever tried to touch the mirror, you'll notice that the finger that you are trying to touch the mirror with gets closer, and the reflection finger tries to get closer as well. When you raise your right hand, your reflection is raising their right hand. So what it basically means is things that are closer to the mirror still appear closer as if the reflection is closer to that as well. And we're going to build on this idea by counting how close it is to the line and then counting how much further past the line it is. Let me explain. So let's just say that we're going to reflect over this line. A, we're going to move first by measuring a distance from A to the line. And we'll say that, I don't know, maybe this is 4 units. It means that on the opposite side, the reflection in the mirror would also be 4 units on the other side. So I'm going to try and create this about the same distance. And this will be A prime. B, which is further away, would appear further away if this were a mirror. And we'll say that maybe this is 7 units. Which means that the distance on the other side would also be 7 units, right? This is 7, this is 4. And this will be labeled B prime. And lastly, C is closer than A, so we'll say that this is 3 units. 3 units to the line, which means that C would be like our finger when we're getting ready to touch the mirror, which means our reflection is getting ready to touch the mirror. It will also be 3 units onto the opposite side. Now, this is a little bit harder to display when you don't have graph paper, but hopefully you get the idea that most of this is done on graph paper, where you can actually count the boxes, count the distance. However, if we did it correctly, C becomes C prime, and A, B, C becomes the reflection the reflection across this line. The object we started with was called the pre-image. The object we ended with is called the image. This is how we can display a flip that has happened across a line that's going straight up and down called a vertical line. This is known as a vertical reflection. There's also one more type of reflection, and what if the line was not vertical, but instead horizontal? So let's just say we have a shape that looks like this. Okay, it's a triangle again, because triangles are easier to see. We have B, A, and C. It means that we're going to once again do the same thing that we did in the previous example. We're going to be measuring the distance from each point directly to the line. We're measuring that distance because the reflection across that line will be equidistant. It will be of equal distance to the line. So for example, C, I would say, is 1 unit, which means C prime is also 1 unit away on the direct opposite side of the horizontal line. B, we'll say, is about 4, and we'll count 4 onto the other side. So if this is 4, this is also 4. And this will be B prime. And lastly, we'll count down A. We'll say A is like 6, which means we'll count down 6 here. This is a 6. This is a 6. And this will become A prime. If we've moved A, B, and C, we've moved the shape. Flipped across the horizontal line. This is known as a horizontal reflection. Okay? A horizontal reflection is flipped across a horizontal line to display that the shape has flipped like this. Okay? The vertical flip, just to show the difference, is flipping the object like this, but instead it flips it over a line like this or like this. The horizontal flip flips like this or down like this or up like this. Okay, that's all for today's video. Once again, they will be easier once you see them on graph paper. Okay, you'll be actually able to measure this distance and it won't seem so abstract as it does on a whiteboard. Hope these videos are helping. Peace.